we'll now start the next module, module 5. Our first topic we'll cover is beta function. Now beta function is written of the form beta of n comma n, and it is equal to integration from 0 to 1 x power n m minus 1 into 1 minus x power n minus 1 dx, where m and n are both greater than 0. Properties of a beta function: beta of m comma n is the same as beta of n comma m. Beta of m comma n can be written as twice integration from 0 to pi by 2 sine theta to the power 2m minus 1 cos theta to the power 2n minus 1 d theta, and beta of m comma n can be split as beta of m plus 1 comma n plus beta of m comma n plus 1. Our first question is, show that beta of m comma n equals integration 0 to infinity y power n minus 1 upon 1 plus y power m plus n dy, which is equal to integration from 0 to infinity x power m minus 1 upon 1 plus x power m plus n dx. So now we know this is we write a beta function x power m minus 1, 1 minus x power n minus 1 dx, integration from 0 to 1. Let x equals 1 plus y. Then on taking a derivative, we get dx equals minus 1 by 1 plus y square dy. As x approaches 0, y approaches infinity. As x approaches 1, y approaches 0. So now this we substitute in the beta function equation. We get integration from infinity to 0, 1 by 1 plus y power m minus 1, y by 1 plus y power n minus 1 into minus 1 by 1 plus y the whole square dy. So now this I reverse the limits, so it becomes negative integration from 0 to infinity, and this minus comes out here, solving that. Over here we have 1 by 1 plus y m minus 1, this 1 plus y the whole square goes over here, so we get m plus 1, and that's how we get this value, and we remove the negative sign. Now we just simplify it a bit more, where you say y power n minus 1 comes from here, so it becomes 1 plus y m plus 1 plus n minus 1. So the plus 1 minus 1 cancels, we'll get m plus n in the denominator dy. Now we know beta of m comma n equals beta of n comma n m, so then I can just swap the places of m and n and still get the same answer, the beta function. And since this is a definite integral, I can just change the variables inside. So that's what I've done over here. I've changed the variables to x instead of y. I'm taking it in terms of x, and I'm swapping the values of m and n. The next part of the beta function will be, show integration from 0 to pi by 2 sine theta power m times cos theta power n d theta equals half beta of m plus 1 by 2 n plus 1 by 2. So now we know beta of m comma n can be written in this form. So if we integrate, now this is what is given to us, integration from 0 to pi by 2 sine theta power m cos theta power n d theta. So now if I take m out, if I take sine theta cos theta out common, I'll get sine theta power m minus 1 cos theta power n minus 1, and now I say let x equals sine square theta, dx equals 2 sine theta cos theta d theta. I can take 2 on this side, and that's how we'll get sine theta cos theta d theta in terms of x. When theta is 0, x is 0. When theta is pi by 2, x is 1. You put 0 and pi by 2 in here to get your values of x. So now we have converted our integration into integration from 0 to 1 sine square theta m minus 1 by 2 cos square theta n minus 1 by 2 d theta sine theta cos theta. This becomes dx by 2. This becomes integration from 0 to 1 x power m minus 1 by 2 1 minus x power n minus 1 by 2 dx by 2. Now the method to solve this kind of a thing is, we know our beta function is x power m minus 1 1 minus x power n minus 1. So we must get a distinct term of minus 1 at least. To do that, we split m minus 1 by 2 into m by 2 minus half. I subtract half, so I have to add half. Same thing I do over here. I subtract half, so I have to add half. Now I'll get one m plus 1 by 2 term over here. Now taking this m by 2 plus 1 by 2, and the minus halves will come out to become minus 1. This becomes of the form m minus 1. This becomes of the form n minus 1. And that's how we get this as half of beta m dash comma n dash equals half, where m dash I'm calling it m plus 1 by 2, so I get m plus 1 by 2 n plus 1 by 2. Again, another very similar type, or based on the logic, we have integration from 0 to 3 dx by root of 9 minus x cube. Now we have to get it in the form m minus 1, mainly in the power m minus 1 and n minus 1 in the power, and the limit should be 0 to 1. So we have to change the limits accordingly. To change the limits, we take x square equals 9y, x equals 3 root y. We take a derivative of this, we get 3 by 2 root y. Now the thing is, when we perform this operation, we get x, as x approaches 0, y approaches 0. As x approaches 3, y approaches 1, and that's what we want. Our limits are changed from 0 to 1. We can convert the dx into here. There's a minor problem. This should be dy over here, so there should be a dy here. Yeah, which is what we have done here. Yeah. So 1 by root of 9 minus 9y, 3 by 2 root y dy. Now I'm taking a 9 out common here. I'll get 3, 3 and 3 cancel. This half I take out common over here. So now I have y power minus half, 1 minus y power minus half. Now again I need a distinct minus 1 term. So over here what I do, I add 1, I subtract 1. I add 1, I subtract 1. So now this becomes half minus 1, this becomes half minus 1. And that I can write it as 1 by 2 beta of half comma half.